Dear students, good evening ma. Today I am going to start Unit 4, Solution to Equations and Eigenvalue Problems. Now, solution to equation. We have two categories. One is single equation, another one system of equations. Single equations either purely algebraic or transcendental equation. Transcendental equation means equations involving algebraic or trigonometric or exponential or logarithmic. Such an equation is called as transcendental equation. For example, cos x minus e power x plus 3x is equal to 0. This comes under transcendental equation. Another one purely algebraic. That is either it is quadratic in x or cubic in x or fourth degree in x. That is purely algebraic. So those types of equation can be solved using Newton-Raphson method. Newton-Raphson method. Now if you see system of equations, you can solve the system of equations by direct method or indirect method. Indirect method or otherwise called as iterative method. Under direct method, we have two types. One is called as Gauss elimination method. Another one, Gauss-Jordan method. Under iterative method, we have Gauss-Jacobi method, Gauss-Seidel method. Okay. So, Gauss elimination method means we will reduce the given system of equations to a upper triangular matrix form. That is, we will make the entries below the leading diagonal as 0 in Gauss elimination method. Right? If you see in Gauss-Jordan method, we will reduce the given system of equations to either diagonal matrix form or unit matrix form. So in both the cases, we prefer only elementary row operations only, not column operation. Right? Now if you see in indirect method or iterative method, we have two methods. One is called as Gauss-Jacobi, another one Gauss-Seidel. But in our syllabus, we have only Gauss-Seidel method. In Gauss-Seidel method, what are the steps we are going to follow is, we are going to arrange the given set of equations as diagonally dominant form. What is meant by diagonally dominant form is, in first equation if you see, we are going to see the coefficient of x. Okay, we will take the modulus of coefficient of x and that should be greater than sum of modulus of other two coefficients, that is other two coefficients of x and y. In second equation if you see, coefficient of y, that is modulus of coefficient of y should be greater than sum of modulus of other two coefficients, that is x and z. Now in the third equation, modulus of coefficient of z should be greater than sum of modulus of other two coefficients, that is x and y. Okay. So in today's video lecture, we are going to see how we are going to solve Gauss-Seidel method using calculator. I will teach you in a simple way how to find out the solution to Gauss-Seidel method. Okay. Now, if you see the system of equations, say 20x plus y minus 2z equal to 17. Another equation 3x plus 20y minus z equal to minus 18. 2x minus 3y plus 20z equal to 25. We are going to solve this problem using Gauss-Seidel method. In this method, we are going to observe whether the given equations are diagonally dominant form. Okay? Diagonally dominant form. That means, if you see in the first equation, the coefficient of x, if you observe, take its absolute value, which is going to be 20 only. So, in first equation, mod 20, which is 20, which is greater than sum of modulus of other two coefficients. That is, coefficient of y is what? 1 and coefficient of z is minus 2. Now, if you observe that 20 is greater than 3, right? Therefore, first equation is arranged in proper format. Again, if you see the second equation, coefficient of y, if you see 20, if you find its absolute value, it will give me 20, which is greater than sum of the coefficient of other two coefficients. Sum of the modulus of other two coefficients, that is here 4. So, again if you see the third question, coefficient of z, if you see mod 20, which is 20, which is greater than sum of modulus of other two coefficients, which is 5. Therefore, the given equation already in the proper format, that is our required form, that is diagonally dominant form, right? The second step what we are going to do is, from the first equation, we are going to write x as, what is x from the above two equations? First equation 1 by 20, 17 minus y plus 2z. And from the second equation, what is y? Y equal to, so y equal to 1 by 20 minus 18 minus 3x plus z. And from the third equation, z equal to 1 by 20, 25 minus 2x plus 3y, right? This is our second step. Third step, what we have to do is, we are going to set y equal to 0, z equal to 0. After that, what we are going to do is, I am going to make use of my calci. I hope it is visible. So, press on. Now we are going to fix it, because we are not going to get the integer values to all the problems. Sometimes we will get the decimal values also. So what you do is, first thing, you press your calculator, fix the decimal places. So 5 times you press your mode. So fix, then say correct to 4 decimal places. So press 4. So you can observe that point followed by 4 decimal places, right? After this, you press on, right? After this, you press on. After that, what we are going to do is, we are going to feed these 3 equations. So for that, first thing what you are going to do is, press alpha, then press this x. So this gives me x. Don't press this usual equal to. Press this alpha and this calc. So that will give me x. So x equal to what, ma? 1 by 20. So put this bracket. 1 divided by 20. Close the bracket. Again open the bracket. 17. Okay. 17 minus I need y. So alpha, y is over here. Okay. minus y plus 2z. Z is again alpha. In the place of z we have what? M. Okay, press M. So close the bracket. So first equation we have entered. So second equation, for before typing the second equation, press alpha and integral dx. Okay, just to split the equations. Then again press alpha. I need y. So y equal to, for pressing equal to, press alpha calc. So equal to, okay, so 1 divided by 20. So put this bracket, 1 divided by 20, close the bracket, again open the bracket, minus 18 minus 3 times alpha this x minus 3x plus z. Z means here m. So press this alpha and then m. So close the bracket. Again we are separating the equations by this colon. So press this press alpha, this integral dx. Then we have to insert the third equation. So third equation, instead of z we have m. So m equal to, so alpha this calc. Now coefficient is 1 divided by 20, close the bracket, again open the bracket, 25 minus 2x, alpha this bracket, then plus 3y. So y is what ma? This comma, right? So I have inserted all the 3 equations, right? Now we are going to, so we have fed everything. Now if you press calc, it will ask for y value. So y is what ma? 0. Press equal to, it will ask for m. M means what? Z. So we are substituting z as 0. So it will give the first iteration. So first iteration, what is it ma? X takes the value 0.8500, then press equal to, it will give y value as minus 1.0275. Then if you press equal to, it will show z as 1.0109. For the second iteration, what I have to do is press calc. Automatically my y value is stored. In the second iteration, what we will put y as? The first iteration value minus 1.0275. Then press equal to, it will give my z value as 1.0109. Right? Now press equal to, keep on pressing equal to. Second iteration, x is 1.0025, y is minus 0.9998, z is what ma? 0.9998. Now if you go for third iteration, what you have to do? Press calc. It will ask for y. My y is now minus 0.99, it is showing that. Then press equal to, m value is what? 0.9998. Now if you press equal to, it will give your x as what? 1.0000, y as minus 1.0000, z as 1.0000. Is that clear? Now if you move to fourth iteration, what you have to do? Press calc. If you press calc, it will ask for y. Y is minus 1. M is what? M is nothing but z, which is 1. Now press, you are getting your x as 1.0000, y as minus 1.0000, z as what? 1.0000. Now if you observe, your third and fourth iteration coincides. Therefore, I can conclude that x is equal to 1, y equal to minus 1, z equal to 1. I hope you have understood how to use calculator to find out the values of x, y, z. Okay. Thank you, students.